registers R1, R2 of a computer contains the decimal value 1500 to 5000. The following instruction is get executed with the 3 address format: subtraction R1, y, R2. What should be the operand y in memory to retain the same value at R1? In order, the execution of the given instruction is first R2 gets subtracted from y and then stored in R1. So for example, this is the meaning is R1 receives, R2 is subtracted, m of y minus R2. Okay, so what should be there in this value? So here we are going to subtract the R2 from the y. So here it can be taken as R1 receives m of y minus R2. So that is 1500. This is initial value of R1 is 1500. 1500 is equal to m of y minus 5000, because R2 value is 5000. To retain the same value 1500, then m of y must be what? Okay, that's what we need to find out. So the y value we need to find out. So m of y should be 6500. Then only 6500 minus 5000 becomes 1500. So option D is the right option. Computer system with 32-bit logical address and paging system for memory management. Let page size is 4 kilobytes and each page table entry contains 4 bytes. How many levels of page tables are required? 1, 2, 3, 4 are the options. So if you want to find out the different levels, first a number of pages we can write. It is 2 power 32 is a logical address space, and each page size is 4k means 12, that is 2 power 12. So it is equal to 2 power 20. This is the number of pages. So to identify each page we require to have 20 bits to identify the each page. So entries into the page table, that is the page table at 2 power 12 is the page size. So if you take 4 bytes entries, we have to divide the page size with the number of bytes in the each entry. So this will be 2 power 12 by 2 power 2, it is 2 power 10. That means 10 bits are required for entry. So number of levels can be decided based on 20 bits divided by 10 bits. So it will be 2 level entries. B, option B is.
These are common data questions, and the given data is: consider a directed graph G with vertex set V is equal to 1, 2, 3, 4 and edge set E is equal to 1, 2, 2, 3, 2, 4, 3, 4 and 3, 1. This is 1, not 11. This is 3, 1. And the first question is: the diagonal of the corresponding adjacency matrix of the graph G contains option A all zeros, option B all ones, option C ones and zeros, and option D none of these. Here vertex set, here number of vertices is 4. If we construct the adjacency matrix, we would be getting adjacency matrix as this is vertex 1, 2, 3 and 4. 1, 2, 3 and 4. So here 1 to 1, edge 1 to 1 is not there. So this will be 0. 1 to 1, 1 to 2 is 1 to 1, 1 to 2 is 1 edge. So this would be 1. This entry would be 1. And is there any edge between 1 to 3? So there is no edge. So this would be 0. And 1 to 4, 1 to 4 is also no edge. And 2 to 1, is there any edge between from 2 to 1? There is no edge. So this would be 0. Here it is given that this is a directed graph. So 1 to 2 is not equal to 2 to 1. This edge is from vertex 1 to vertex 2. So that is not equivalent to 2 to vertex 2 to vertex 1. So this entry would be 0. So this entry would be 0. And is there an edge between 2 to 2? There is no edge. And one edge between 2 to 3. So this is 1. And 2 to 4 also. This is 1. And 3 to 1, no edge. 3 to 2, no edge. 3 to 3, no edge. 3 to 1, one edge is there. So this is 1. This is 0. And 3 to 4 is also one edge. So this would be 1. And there is no edge from vertex 4. So this whole row will be 0. So this is the adjacency matrix. Here the question is the diagonal of corresponding adjacency matrix G contains, here diagonal elements are zeros. That means there is no self loop in the given graph. That's why these are all zeros. So here correct option is option A. And the second question for the same data is, for the given graph, second question is for the given graph G, if BFS, breadth for search, is initiated from vertex 1, then the vertices of G are visited in the order option A 2, 3, 4, option B 2, 4, 3, option C both option A and option B, and option D is none of these. Here the question is for the given graph G, if BFS is initiated from vertex 1, then the vertices of G are visited in the order. Let us construct the graph, directed graph for the given edge set. If we construct the graph, we would be getting the graph as, here the vertices are 1, 2, 3 and 4. So if we see the vertex set 1 to 2, 2 to 3, so there is an edge between 1 to 2, and 2 to 3 is also one edge, and 2 to 4, 2 to 4, and 3 to 4, 3 to 4 and 3 to 1. So this is one edge and this is the other edge. So this is the directed graph for the given edge set and vertex set. So here the question is, we have to do BFS starting at vertex 1. So if you start at vertex 1, we can in BFS the next vertex would be, in BFS we visit the vertices in level by level. So next order is from vertex 1 to 2, then 2 to 3, and then 4. So this is one order. From 2 to we can go to either 3 or 4. So if we go to 3, this is the order. From 2 to, if we go to 4, then 2, 4, 3. This is the order. So these two options are possible. So here correct option is option C, both A and B.